In today's video, you'll learn how to solve equations and check your work. Here are 5 different examples to show you how to show your algebra work and check your work. First problem is negative 15 equals negative 4m plus 5. We want to get m by itself, so we need to get variables on the right and numbers on the left. So instead of adding 5, we'll subtract 5 on both sides. And now we have negative 20. Negative 15 minus 5 is negative 20 equals to negative 4m. Now we want to isolate for m. So the opposite of negative 4 times m is negative 4m divided by negative 4. And we do that to both sides. So divide both sides by negative 4. And then we're left with m equals to 5 because negative 20 divided by negative 4 is 5. Now we check our work. Instead of writing m, we'll substitute it with the number 5. So negative 15 equals negative 4 times 5 plus 5. And we're checking our work to see if our answer is correct. Negative 4 times 5 is negative 20 plus 5. And negative 20 plus 5 is equal to negative 15. So negative 15 does equal negative 15. Therefore, m equals 5 is the correct solution. Our next problem, v plus 9 over 3 equals 8. So the first thing we need to do is get v plus 9 by itself. So instead of dividing by 3, we'll multiply by 3 on both sides. Once we multiply 3 on both sides, we're left with v plus 9 equals to 8 times 3, which is 24. And if we want to get v by itself, instead of adding 9, we subtract 9 on both sides. So now we're left with v equals to 24 minus 9, which is 15. We then check our work. So we have now, instead of writing v, we're going to write the number 15. So plug in 15 plus 9 over 3 equals to 8. 15 plus 9 is 24 over 3 equals to 8. And 24 divided by 3 equals 8. And 8 does equal 8. Therefore, v equals to 15 is our correct answer. So our first example just involved integers. Our second example involved a fraction. Our third example will involve both integers and fraction. So we have negative 4 equals r over 20 minus 5. Okay, we want to get r by itself, r over 20 by itself. So the opposite of minus 5 is add 5. So we add 5 on both sides. Negative 4 plus 5 is 1. 1 equals r over 20. Now we need to get r by itself. So the inverse of divide by 20 is multiply by 20 on both sides. And we get 20 times 1 is 20 equals to r. Now we check to see if our answer is correct. So we write down the original problem, negative 4 equals, and instead of r, we write 20 over 20 minus 5. 20 over 20 is equal to 1. Bring down the rest of the problem. 1 minus 5 is negative 4. So we do get negative 4 equals negative 4. Therefore, r does equal to 20. Okay, so our next example involves decimals. Let's choose. Okay, so we need to get z over 4 by itself. So the inverse of positive 6.5 is subtract 6.5 on both sides. And we have z over 4 is equal to 3.5 minus 6.5, which is negative 3. Now we need to get z by itself. So z divided by 4, the inverse of divide by 4 is multiply by 4 on both sides. Negative 3 times 4 is negative 12. Let's check to see if our answer is correct. 6.5 plus z is going to be negative 12, so I substitute that in, over 4 equals to 3.5. Negative 12 divided by 4 is negative 3. 6.5 minus 3 is going to give us 3.5. and 3.5 does equal to 3.5. So we know our answer is z equals negative 12 is correct. Our last example is going to involve decimals, but this time involving also the distributive property. So we distribute the 1.22x and to the negative 3. So 1.2 times x is 1.2x. 1.2 times negative 3 is negative 3.6. And that equals to 2.4. We want to get 1.2x by itself. So we add 3.6 to both sides. And we're left with 1.2x is equal to 2.4 plus 3.6, which is 6.0. Then we divide both sides by 1.2 to get x by itself. And 6 divided by 1.2 is going to give us 5. So now we check our answer. 1.2 times x is going to be 5 minus 3 equals 2.4. 5 minus 3 is equal to 2. So we do 1.2 times 2 equals to 2.4. And 1.2 times 2 is 2.4, which is indeed equal to 2.4. So x does equal 5.